То есть 3 года назад.
You're all. Hello? Am I on? Am I actually? Okay, so I'm just doing this for the stream. Hi, everyone. You're all far too well behaved. I cannot remember a single preceding HelsinkiJS when everyone was sitting ahead of time. Applause for yourselves, I guess. Yay. Welcome to Vincit, where we are today. And we've got a lineup of 3 very fine speakers for you today. But before we get to those, just thought I'd mention a couple of future-looking things. Our next meetup after this one is coming actually relatively soon. It'll be on the 4th of December in the middle of Slush, which we haven't really done before, but Slush gives us an opportunity to get Sarah Dresner from Microsoft as one of the speakers. Will be at Citrus Solutions. More information on that one shortly, but I thought I'd just let you know of that ahead of time. Then more even forward than that, of course, next year in the spring, there's going to be the next React Finland conference. That one's information on that is going to be getting more public relatively soon, but I just, small pitch on that one here. If you Google for it, you'll find the website and so on. But yeah, Vincit, in case you were not aware, is a very fine software development house, which happens to employ me among other people, and Timo, our first speaker as well. And as with all of these, of course, the hosts would not be, underappreciative of me mentioning that, yes, we are hiring. If you're interested, Emmy over there, who's going to be around for the evening, is the person you ought to talk with. If you want to talk with more of a developer person, there's me, there's Timo, and there's Fedu. You can ask us the questions that you'd rather not ask HR sort of people, if you're of that sort of a persuasion. But yeah, so first up today we have Timo talking of Zeit. He practiced this speech for us here at the office 2 weeks ago. Was it about a week ago when Zeit 2.0 got released? So he's rewritten his whole speech since then, and apparently it was a bit of an annoyance for him. And coming up after Timo, we have we have Jarno, speaking of using fuzzing and property-based testing to find bugs in a React Redux application. Then we're going to have a break after the second talk and then go on with Juha-Matti Santala and experimenting and learning with Codepen. And the reason why I'm talking into this microphone here is because today we're live streaming to YouTube, just so you're aware. So any antics that you do, sure, we'll tag you in there if you really want to. But we'd rather not have you do any really annoying antics that would mean us getting blocked from YouTube because it's going on Vincit's channel. So please behave. As you have done marvelously so far, at least. But let's start. Here's Timo.
Fedu, is it okay if I change the HTML?
Yeah. Oh, yeah.
This one. And thanks, Emily, for introduction. My name is Timo Tuononen. I work here Vincit as software developer. I also work in my own startup as CTO, where we have been building chatbots. And we have in our startup, we have been using Zeit as our cloud platform servicer for about 1.5 years. And now I'm going to talk about how their cloud system is a bit different than the others we might have been using, why I've chosen it, and so on. And as Emily said, yes, I've been using now 1.0 for a quite long time. And 13 days ago, they released 2.0, and I haven't really done anything with it, and it's completely different. So this is, even in world of JavaScript, really, really blazing new technology that even I'm not sure how it works, but let's find out together. First, a bit about Zeit. Even though the name suggests, it's not a German company. It's actually a kind of global company with lots of open source developers coming together. A couple of founders are from the University of Helsinki, of previous teachers and students there. And what they do is their mission is to make cloud computing as easy as mobile computing. And I think they have been doing really, really well. And I've been loving to using their product for cloud as long as 1 year. And that's mainly because I'm by no means I'm a DevOps guy. I hate DevOpsing. I hate using AWS. I hate using Azure. I hate dashboards. You know, some of you know how I feel about those. It's not that fun. But with Zeit, and as I'm later going to show you, I don't need to watch dashboards. I can just code and use some really, really minimalistic command line interfaces. And then first, as I said, Zeit is kind of founded by people who have been working really much in open source, and they also have been giving back to the open source. And one of their products is Next.js. So there have been some talks about it. It's a server-side rendering React tool. It's really, really great to use. I really recommend you to find out if you haven't been testing it. It's really fun to use. They also have Hyper, which is a command line client. You will be seeing it on my screen later on. It's also kind of cool. It's JavaScript made, and you can actually write your own CSS files if you want to customize your command terminal. It's fun. But yeah, and then of course they have a couple of domain, CDN, certification, DNS, all the tools you need for cloud. But we are here to talk about the actual cloud environment a bit more. What now aims to do, and this is purely 2.0. The version 1 was more kind of Docker container based, and this is all about lambdas. I mean, everything is all about lambdas. I think their phrase here is global serverless deployments, which means as global, with now, you are able to deploy all over the world within one command quite easily. They have data centers in, I think, East Coast, US, West Coast, US, Europe, Sao Paulo in Brazil, and so on. You can easily reach the whole globe. And actually a bit interesting part in now is that, as usually when you think about cloud service provider, it's AWS, it's Azure, it's either AWS servers, it's Microsoft servers. Now it's not having their own servers. They are buying a lot of computation time from AWS, Azure, Google. So when one if there was happened to be outage like there was in AWS once a couple of years ago, there's still going to be, your deployment is still going to be alive in some other instance, especially in Google or in Azure. So they are just buying the time from every other provider and then using their own platform to make me do easy deployments. And as I said, that's about the global part, and then about the serverless. Everything is serverless, everything is Lambda. Even if you deploy your own backend server, it's going to be wrapped around Lambda. So right now there's not any kind of always on servers. Everything is Lambda, everything is, pricing is computation time based, and you can only get Lambdas there, which is actually kind of cool when you think about it, as the future has been shifting towards more the serverless side. And of course, there's a downside. If you need something to be always on, then this is not possible with this one. But as you can later see, it's going to be really easy and really fast to deploy Lambdas, as far as I have been using AVS, it's kind of a bit of pain because you need kind of gateways and you need to deploy your code and then run. But we will see how easily we can do it here. And one final thing about global serverless deployments is the deployment part. And this is where it kind of gets unique, what I haven't found anywhere else. Every time you deploy, it's going to be a unique entrance. It doesn't. If you are going to deploy in AVS, we have a kind of deployment, maybe our development stage. Then we deploy over it. We might be able to roll back, but still we have one environment. Or for us, we have development, staging, demo, production. You guys know this. It's a pain in the ass to copy those. But every time with now, we deploy a unique one. And this makes kind of all those different kind of environments relevant because every environment is like its own. And when you want to go product, you just give in the alias, give your production domain to the development, and it's live. Which is really cool when you start think about it. I'm going to show you a bit more, but I promised to show you many things, and I don't have that much time left, so I think it's time to go programming a bit. As I usually know, the talks go from good to worse when people start live coding, so I'm going to do live coding and live DevOpsing, just to be sure that everything is going to be going out of plan. Can you guys around? Yeah, thank you. So let's start about making a new directory. Let's go to HelsinkiJS. And actually, I forgot one thing. Let's go up. What we are first going to do, we are going to deploy my slides. Wrote the folder, slides. Well, and of course, I failed already. Slides to HelsinkiJS. And as you can see, this is an empty directory. Now we are going to have to do a bit of configurations. And this is probably way too small to anyone to see anything, but let's see if we can add it up a bit. Yeah, you can probably see something from there. And now we are going to add node.json, which is basically the configuration file. Because we are a bit short, I'm going to cheat a bit and copy. We don't need those. Yeah, there's extra comma. What do I need? Yeah. So, and this is going to be the most minimal configuration we are going to use when we are going to deploy. We specify the version, which is going to be 2.0. We specify the name, HelsinkiJS. Let's add, just for redundancy, let's add the year there. And then this is going to be the key here. We are going to use this kind of builders that now has kindly provided us to their cloud. We are going to say, use every PDF file you find and deploy it as it would be a static file. All right, let's save it. Let's see what it does. We are in right folder, and only command we are going to use to deploy is now. And actually, I'm using my startup account, hence the name, Achievely. And we wait a bit. It's usually a bit slower first time. Actually, when I'm doing the code run to train this new 2.0, this actually crashed here. But it worked on the second time. I don't know why. But what we are going to basically do here is, not that way, that way. I'm gonna show you in the meantime while that waits. Presentation, yay. You can see now on the left-hand side of the screen, we get an URL, and we are ready. So what does that mean when we get an URL? It means we can go, that's again way too small. We get a deployment URL. And by the way, this is static, so this is global. This is available right now in all the data centers, West Coast, East Coast, Sao Paulo, Brazil. And it's kind of, we deployed our folder, and we are going to create here a bit more. We are going to create kind of monorepo-like environment where we are going to be static files, a bit of front end, a bit of back end, all in the same folder. If I would add index and .html, it would show this, but now it shows the root. And as you can guess, we can find my slides right there. So we deployed something static there, just like using S3. It was quite fast, but that's still like just deployment. Let's do something a bit more interesting. Let's create React app called frontend. Kind of boring name, but we are programmers, right? And I'm pretty sure everyone has done this at least once, so I'm not going that much into detail here. We are going to change a couple of files there, so you can see that this is actually happening and live. Yay, we have that. Let's go back to our code. We can see we have frontend filed. Let's add here something more interesting. Hello, HelsinkiJS. And what we want to do, since this is create React app, we want to build a static file. We don't want to deploy any kind of development server. We want to deploy a full create React app. And to do that, we need, again, a bit of configuration, not that much. A bit, maybe for some it might be annoyance, but we need to copy this, create so-called now build script here, and do one extra trick, because now accepts for some reason it wants dist folder instead of build, so we're just going to rename it. Is there a bug? It should be cool. Yay, now build. And because we are short of time, I'm going to just check. Yeah, it's about right. And next. Now we have the front-end side ready. And now we need to add a new builder here. Yay. We can add these 3 different kinds, and where we are going to say, take everything that is front end and take package JSON file, use now static build, which means it's going to build a static. It's not going to be static as the PDF. It's just going to use the CI system and build it for itself. And a bit more cheating, of course, since I don't remember this yet. And we need to, since this is like the monorepo, we have this one folder, and Zeit is using the folder system as an routing. We need to add some bit extra options here. Do I have extra comma there? Yep. Why I'm using this small screen? Yep. Where we are going to say if everything is static, please use the front-end static file and let the front-end index do all the routing. So if we are going to use React router or anything like that, the Zeit now would not use the routing for us, but instead let the front-end do it. I'm hoping I have everything all right here. I changed that. Yay, so we should now be able to try it again. And again, right, we are now, now you can see we are creating a new deployment. We can still access our old one. It's never going to vanish before we delete it. Instead, we are going to create a new one. And it won't upload our PDF file because it's already there. Instead, it's going to, as you can see, its PDF is ready. Instead, it's going to build, hopefully, if we got everything right, build us a beautiful React page with proper configuration. And again, we get an URL. We can see it's still kind of doing something in the encrypt, and when it goes red, you know I fucked up something.
Where did you specify the build command? Like you type the now dash build.
Yeah.
How it knows to run that script?
It's because I'm using the wrong way builder here. Here you can see I'm using this static build, so that's where it knows it's going to go to package.json and use the now build command. It looks like at least it builds. Something is working, and we can see we are back at here with our new deployment. You can see this is our old one, new one. Let's zoom it up. We have front end, and we have create wrapped up and running. And as you can see, yeah, cool. There's more to come, more to come. And as you can see, we are using production version. This is not any kind of deep development server, but at least we have front end and we have some static files. Maybe should we add a bit backend there? And again, because I only have more like 3-ish minutes left. Let's cheat a bit more. Let's create the backend folder. Go here. Oh, those files. Backend. Okay. And now let's take everything out there. Yep. So, what I just did, I created a backend folder. In there, I copied the most simple GraphQL server that there is able. This is straight from the tutorial. Only changes I've been made is like add mistyped Helsinki there and added the path to backend, so we will not mess up our routing. Everything else is here, default ports. I'm not doing anything fancy. Package.json looks pretty dull. There's not even a start script here. Just double server, express GraphQL, and we have our yarn lock. Just to be sure, I'm gonna do one thing because that failed during. I'm going to go to backend, install yarn, so we are sure that there's everything we need. I'm not sure if that's required yet, but next when we deploy, hopefully, thank you. Hopefully we are going to have backend that's going to serve us our GraphQL endpoint saying hello HelsinkiJS. Well, let's see. Hopefully one last time. No, of course, I failed something. What does it say? Missing start. Oh, did I forgot to? Sorry? Oh, sorry, I'm in the wrong folder. Oh, thank you. Luckily someone is paying attention. And now, hopefully for the one last time. And as you can see, soon it's once again going to check it. What files have I changed? And it should not deploy my frontend anymore or my PDF files. It should deploy my backend. As you can see, that's already ready, and frontend should be ready soon. And then we are going to wait a bit before we get our backend. And this is kind of the most exciting part of everything else. Yeah, we can see at least we didn't break what we already had there, and it's even building. I'm just going to do one more thing here at command line. As I said, now offers also Zeit also offers domains and CDN. So as I said, when we go live as production, we just add an alias. So that's what I'm planning here to do once the backend finished building. It usually takes more time when it's first. And here you can see we have Lambda called backend. And now one final thing. Let's create an alias. As I said, when you are ready to go production, add alias. I happen to own a pretty boring domain name, but Don't ask how we got it. HelsinkiJS.officeship.work. We were supposed to be and create a ship and so on, so we bought the domain, but doesn't really matter. Let's go. What was it? HelsinkiJS.officeship. Oh, I have already used. Yeah. Here you can see once again we have our front-end slides and backend, and here you can see we have beautiful GraphQL endpoint ready to say hello, and that's pretty much that. Thank you. Yay, probably time for some questions if anyone is interested. Yay, Juhis.
So you mentioned that every time you do the deploy, it will create a new one.
Yes.
If you do the alias stuff, do you have to then redo that every time you change something?
Actually, no. You can add the same, now just JSON file. You can add alias command, which will automatically give it the alias. Or you can even hook it with the GitHub. So every time you deploy the master, it will alias it. And yes, here.
Have you used Code Sandbox? It's basically VS Code on the browser.
Yeah.
And it supports Zeit now deployments as well, so you don't even have to install those creepy IDE environments on your computer anymore. You just can code your React app in the browser and deploy it with one click in Zeit.
Oh, that's pretty cool. Though I still kind of like my ideas. A bit. Yep. Yes, please.
So can you include some environment variables, for example, with the aliases?
Yes.
So that you can, for example, provide different secrets to live and dev? And
Yes,
so on?
of course you can. You can even now support so-called secrets that you can, in your own cloud environment, you can create secrets and then you can use those as an environment variables anywhere. It's pretty cool. I actually have a couple. I have a couple of certificates that I have in secrets and base 64 encoded. And I'm just whenever I need it, I'm just going to use use this secret from the cloud. And about usually I get the question about pricing. Pricing is actually pretty fair right now. If we go Zeit.jo, go just no, and pricing. So this is actually, I think this is pretty decent. As a free tier, you can get quite a lot of stuff for free. So like 1,000 invocations per day, that doesn't cost anything. 1,000 builds, 100 gigabytes of data, and so on and so on. So it doesn't really cost you anything if you want to try it out. Also, yay. Any more questions? Yes, here.
So pricing in practice, if you have like your startup or whatever, how much are you paying? Like that?
Currently we have like, we are kind of still in the movement from 1 to 2, but we are paying like 10-ish, 20 maybe bucks a month. Pretty low, but it's still kind of on the move because, as I said, the pricing and the 2.0 version came 14 days ago, so we haven't really got the new bill yet, so we are not sure. But it's actually pretty cheap. The free tier is awesome. Yeah, Henrik.
You compared this to the AWS and services like that. So like how this service handles like auto scaling and load balancers and whatnot like.
It's everything because, well, first of all, everything is serverless, everything is Lambda, everything is already auto scaling. So it's kind of built in. The auto scaling system is built in because you can. Yeah.
So who is this for in that sense? Like because in AWS you can configure all these things.
Yeah, if you don't want to configure it, if you want just to use. If you are like development team of 1, 2, small team, you don't need a DevOps guy. As you can see, we were pretty fast. I think it took us 40 minutes to get them back and front end, everything up and running. And as you can also see, where was our? Yeah, well, the HelsinkiJS, it has also an HTTPS certificate already with our domain. So we got even that already as well.
So it's targeted to the like groups without DevOps guys and stuff like that.
Or you can just, kick out your DevOps guy out of your company. Yeah. Anything else? If not, I'm here all night. If you want to come talk to me a bit more. But that's that, and let's take a next speaker.
What about the audio? Is it fine? Nice. All right. Hey, I'm Jarno. This is the title of my talk. And actually, I'm going to have to go ahead and reconfigure my displays really quickly. Oh, there you go. Looking for my cursor. Success. All right, let's start again. So, hi, I'm Jarno. This is the title of my talk. I work for a company called Futurize, and yeah, we're gonna break this monstrosity down immediately. So, what is fuzzing? Well, here is a definition slide. They're always amazing. This is an okay definition. I think this is maybe a better one, a simpler one. Fuzzing is just feeding random inputs to your application, trying to make it crash. Android Studio has a thing called the monkey tester, which will just send random touches and scrolls and taps and whatever to your application, like really rapidly, and try to break it. That's fuzzing, definitely. This is sort of the same thing as well, though this is clearly a smarter monkey in that it kind of knows that bugs tend to lie within like boundaries of values, so it clearly it knows a bit more, but it's still effectively just slamming the keyboard and hoping to break something. All right, so what is property-based testing then? Another definition. I think this is maybe a bit better, but I think explaining property-based testing is a bit easier via contrast. So if you compare this to your standard unit testing, where you usually have an example input in your code base, and you give that to your thing, your application, your function, then you expect some specific output to come back at you, and then you can compare that to the expected value. So with property-based testing, instead, we run the same test hundreds of times, and instead of using a hard-coded example, we generate the inputs that we give to the function. But if we generate the inputs, how do we know what to expect from the output? Well, this is where this explanation gets a bit tricky. And usually you see something like this maybe as the sort of simplest possible example. We talked about verifying properties of the output, and this clearly verifies a property. But yeah, honestly, I always find these kind of examples sort of puzzling. Using the definition of the function to check that it works is, I don't know, it feels kind of useless. all right, that was a pseudocode example. This is an actual code example using JS Verify, which is a sort of the de facto property-based testing framework for JS. But still, I mean, this doesn't really look that approachable to me, at least. It might be because I don't know Haskell, but you know, I would love to enjoy the nice things in life without having to learn Haskell. So, so part of the point of this presentation is that none of like this topic isn't very approachable, and I'm trying to make it approachable by using concrete examples from a React Redux application that probably people in this crowd know. Yeah, and the title of this talk was using fuzzing and property-based testing. Like, is this one or the other? I don't really know, and I'm pretty sure that somebody will disagree with my definition, but you know, is what it is. Fight me. And also, I think this is a bit pointless for this audience, but oh well. The core idea of Redux is to model your application as a deterministic state machine. And the important property of that is when your app state changes, when you give an action and the current state to your app, you know that if those are the same, you're going to get the same output back from your sort of state transition, state change function. So yeah, it has to be deterministic. This sounds really simple, but it's also really easy to break whenever you do anything having to do with randomness, like you generate a new ID, or if you do anything having to do with time, if you touch date.now, for example, or if you go over the network to get something, I mean, then basically all guarantees are out of the window. You might get anything back from your function that used to be so nice and well-behaved. All right, and this has like some practice in it as well, in that this is based on an actual project that we have been working on. The client in this case is FIBA, the International Basketball Federation. We have been building various projects for them for quite a while. This is one of them. This is a tool for planning a FIBA 3x3 basketball event. This is kind of what the UI looks like. Yep. So you use this tool to set up the structure of your competition. You choose which teams go into which starting positions, how they progress through the event, how the winner gets chosen, and so on. And eventually there's also a UI for setting the order of the games, when they are played, on which court, and so on. Yep. So the sources of complexity for an application like this is, first of all, we have the official FIBA basketball rules, which we have to follow, obviously. The data model is not only ours, it's actually shared by a couple of different parties, and we cannot change it sort of willy-nilly. We have thousands of players, teams, courts, etc., and eventually navigating all of that in your head gets kind of exhausting or even impossible. We try and not duplicate any data. So if you have a player that is in different teams, instead of storing the player multiple times, we're going to have a reference to that player from those teams. We have, I don't know if this is a very good way of saying it, but we have a lot of these cases where, based on the rules, if something over here is this way, then something over here cannot be that way, and these have to be enforced somehow. And finally, we don't actually ever delete anything, lest valuable data is lost, so things are just marked as deleted, which is a fairly common practice, I guess. To combat this complexity, we have our standard laundry list of QA practices. We review all of our code. We use TypeScript so that at least the dumbest mistakes are hopefully caught by the compiler. We have a pretty good test coverage. We have unit and UI tests. We have lots of assertions in the code so that if there's obvious things that seem to be wrong, say like the team count of the player count of a team is -1, then you know it's again the person ordering the lizard. It's probably not correct, and the app just knows to throw an assertion failure and crash. And finally, if things go wrong in production, we collect a stack trace and an application snapshot for later analysis so that we can figure out what goes wrong. My point is that we tried. We used the normal QA practices, but still we felt like there was a bit too many bugs slipping past us. And these were not the kind of bugs which would loudly blow up in your face, like an application crash or something, but it would be the kind where you're making your schedule or your competition, and then you stop and think and really like look at the data, and you realize that it doesn't make any sense. There's some like flaw in the data logic, or either in the basketball sense or in the application sense. Now, a surprisingly good method of catching these kind of bugs is actually just clicking around manually. And we did this, of course, but then this works best for these kind of loud crashes where you can just click around really fast and then something either blows up or everything was fine. But then you might actually miss these sort of subtle bugs where things aren't quite correct, but unless you really stop and think, you don't realize that. And also, there's a fundamental limit to how much of this clicking around you can do by a person. We are a team of a few people. We have a finite budget. And even if you test that thing A and thing B both work, you don't really know if thing A and then B works, or if you do first B and then A, if that works. And this is like a really fancy term, but yeah. The point is that the search space, when you're looking for bugs, the search space is incredibly large. And you cannot basically just try everything because it's not possible. Not for a human, and usually not for a machine either. So we started thinking, because this like manually clicking around is still a pretty good way of finding these kind of bugs, could we automate that clicking around and also like automate that checking whether it makes sense or not? And this is where this intro finally comes back to the topic of this presentation, in that the clicking around is sort of the fuzzing part, and then this checking that things make sense is the property-based testing part. And in Redux terminology, or rather, the fuzzing would be dispatching actions, and then checking these invariants would be testing that things make sense. We'll get to the invariants soon. So we built this small tool for doing exactly this. It creates a Redux application in memory. Then it starts semi-randomly dispatching actions. And the symbols that you see on the screen, they are indications of what the app is doing currently. Some of them are dispatches, some of them are invariants being verified, some of them are some other things. It doesn't really matter, it just means that it's doing something. And once it reaches the step count limit, which is very small for this demo, it's just going to stop and start over from scratch. There you go. This is what it looks like when it finds a bug. You get your error name, stack trace, expected and actual values. And then this is written to a file, and then and that file actually includes all the actions that we have taken thus far. This becomes sort of important later. And then it again starts from the beginning, and then you can later come and collect the file and examine it. So how does the tool work? Well, it's made of surprisingly simple parts. And this is how we get started. We create a test application and an HTML renderer, which can render that Redux application using React to an HTML string. Then we dispatch some initial actions so that we get the app to the known base state. You don't need to be able to read all of this. It's just to prove a point. And finally, we give this app instance back to the caller. And this is important in that if you call this function 2 times, you're going to get 2 completely independent app instances that you can use and then throw away, and they don't interfere in any way. Then we have getters, which are simple functions for accessing the UI. We use Cheerio and these very traditional CSS selectors for extracting elements from the UI and then turning them into text. Or rather, this one turns the round headings into text and makes them easily accessible to the rest of the application. So it's just a convenience layer for getting stuff from the UI as a user would see it. Here's the full list of getters that we have. It's mostly there. I mean, most of these are actually not that much more complicated than the one that you just saw. Then we have step functions, which describe something that the user might do. And these use the getters to kind of read the UI and then dispatch 0 or more actions based on that. And yeah. Here's the step functions in a list. Then we have invariants, which are effectively checking that things make sense. This one just checks that the round titles go from 1, 2, 3, 4, 5 instead of, I don't know, 3, 5, 2, 1 or something. It's like, these are usually very simple, but they end up being powerful when you have lots of them. And here's the ones that we have. Then there's the repro code, which I mentioned this before. This gets invoked when we find a bug, and it just takes a list of actions that have been taken and writes out code that basically dispatches those same actions in order. And we're going to see a better example of this in a bit. Finally, to tie all of this together, here is the actual runner. Again, you don't need to read all of this. It's mostly here to prove that it's not very complicated because I could fit it on a single slide. And yeah, in the beginning, we just start the app. We create this app instance. Then we choose and take a random step, and that will then dispatch any actions that it might do. Then we check all the invariants. If nothing blew up, then we just go on to the next step. And if something broke, then we invoke the repro handler and then start over from scratch. There's a lot more nuance and interesting stuff, mostly in the steps and invariants, but I don't really have time to go into them. But yeah, talk to me later if you're interested. Yeah, so was this useful? Yep. The kinds of issues that we did find were broadly in 3 categories. First, we got the plain old crashes, which were the kind of things, the uncaught errors, kind of cannot call method blah of undefined, that good stuff. And then also these runtime assertions. So if you had, for example, a player count of -1, then if the app blows up with that, it's just a crash. Here we had a bug where when you went over a magical limit in the team count, we just got a crash for some reason. And here is the issue that we created out of that. So first, here's a screenshot. Then we have the code that was written by the repro module. So it begins with a comment block that has the info about the actual error and the stack trace. Then we have a few lines that bootstrap the application. And then we get the action replay, which is just all of the actions serialized in order so that when you execute this file, it's going to first start the app and then like take all the actions that you had to take to get into the broken state. And there's lots of them. They keep going for a while because usually it takes a long time for the fuzzer to actually find anything. The second category is the sort of business rule violations. These can be the kind of assertions that I mentioned, or they can be these invariants which are programmed into the fuzzer. So the assertions are built into the app. They are pretty lightweight. The invariants are built into the fuzzer, and they might take a bit more time to check. I don't really have time to fully explain this one, but we had a thing that we had a sequence of actions could take you into a state that ended up violating a team placement rule, and the fuzzer caught that with one of the invariants that checked that all the teams are properly placed. And finally, we got some false positives that are results of the not actually being an actual human clicking around using a mouse, but we're dispatching actions. So there's like this slight disconnect. This is an example. Well, yeah, again, kind of not going to explain this too thoroughly, but we had a case where if you were an actual user, you would end up like dispatching some menu would collapse, and that would sort of accidentally protect you from the bug. But because the fuzzer just dispatches actions, it was actually possible to get our state machine into a broken state. So yeah, still a bug. It wouldn't actually hurt any users, but yeah. So lessons learned from this. First, we probably should have done this earlier. We started this towards the end of the project where we were realizing that we actually want to up the quality of the product because it was a particularly quality sensitive product, whereas like some others might not be, this was. So yeah. Initially we had a thing called a simplifier. Sometimes in property-based testing these are called shrinks, where the way it worked is that it would randomly pick a sequence of actions. Like when you have a bug, it would randomly remove a sequence of actions from in between and see if we can still reproduce the same error. Like the perfect case being that, you know, there's a bunch of useless stuff in between, and then towards the end, we do the thing that actually makes the app blow up. So if we manage to remove all the useless crap, we're going to have a much nicer and smaller test case or rep profile. But as it turns out, this is going to take forever for a machine because, again, the amount of permutations is just massive. And also for a human, it's usually painfully obvious. You just look at the repro towards the end of the file and you see the last couple of steps that are usually pretty simple to see. Like, okay, well, this shouldn't work that way. And then it's, yeah. We ended up removing it because it was honestly the most complicated part of the entire fuzzer and it was pointless. So yeah, good riddance. Yeah, and speaking of the repro code, it was just, I think one of the findings was that this was genuinely useful. When you invoke the repro code file, the app starts up, it dispatches all the actions, and then it leaves you in the broken scenario. So if it's one of those cases where the app blows up, you can pause your debugger and you can inspect everything, and you can even use your Redux time travel to go a few steps back and then a few steps forward. And then the truly mind-blowing bit, at least for me for the first couple of times, was that when you then fix the issue and then run the same code again, it's actually not going to leave you to the broken state, it's going to leave you to the correct state because you fixed the bug and you took the same actions again and now the bug is not there anymore. So yeah, I really fancied that. This is just a note. We actually had very few false positives, which I would have expected us to have more because, again, it's not an actual user. It's just the machine like dispatching actions really fast. Oh well. And the usefulness of this approach really grows as you start adding these invariants and steps. Initially, we only had a few, and we thought that, you know, it's probably going to find something if it runs long enough. Didn't find anything. We started adding these more. You basically give the app both more ways to break the app, or rather, you give the fuzzer more ways to break the app, and you give it more ways to say, like, identify the broken scenarios. Limitations. We talked about determinism. We have to have the same output for the same input. Otherwise, it's pointless to have these repro codes because you run the same things again and you don't have the bug. Then you run them again and you have the bug. It's not nice. For the same reason, you have to have the actions JSON serializable so that you can actually write them down in a file. And the apps need to be isolated so that you can run several without them interfering because that's just, I don't know, nice. And the fuzzer only ever looks at the present state of the world. It has no memory of the past and it has no plan for the future. So it's just like a really dumb thing that does something and then looks at the world like, is everything consistent? All right, and then it does it again. So it's really hard to kind of like make more complicated scenarios out of this. You probably could, but then you probably would end up debugging your sort of bug finding code and it's, I don't know, it doesn't sound productive. And like I said before, the search space for bugs is incredibly large, so you shouldn't expect this to find all the bugs. In fact, initially I was running this on my laptop, and it immediately turned into the helicarrier and flew off with its fans spinning, and it just like exhausts any power that you can give it, and it still is not enough. So what we started doing is we started renting a 16-core machine off of DigitalOcean every night, leaving the fuzzer running there for the night, and then in the morning observe the mess, fix the bugs, and then do the same thing again over the next night. And I find it kind of fascinating to put this into this linear perspective, in that if you think about this 2 days over 16 cores running continuously, it is effectively the same as 1 month of somebody like furiously clicking around in your app trying to break it. And all of this costs $23. It's way less boring. I wouldn't want to spend a month doing that. And yeah. Then one less obvious thing is that during this run, actually, I think we found 2 issues. The fuzzer came up with 2 issues, and it might be intuitive that you let it run for like 5 minutes or 15 minutes or, I don't know, 3 hours, and it would, you know, find everything that it can. But in fact, it took 20 hours of grinding for the first issue to appear, and then 40 hours, or 20 more hours for the second one to be found. And even that, it feels like it just, because effectively it's just guessing, and the space is huge. So yeah. Also, this doesn't fit every project. In our current project, for example, we're not doing this kind of testing. I don't really know why, except that our current app is perhaps not as much of a rule-based system, and there's other things like asynchronicity giving us grief, and this is a tool for a specific kind of quality problem, and we just haven't felt the kind of pain, I suppose, that would trigger using something like this. And finally, this doesn't generalize easily in that you cannot just npm install fuzzer, and that's also why I haven't made this into a framework or anything, because almost all of the code is actually app specific, and there's not that much of it anyway. So I do have a link to the code at the end, like if you want to take a look at it, but yeah, it is very app specific, both in implementation and where it actually fits. Finally, some future work that we didn't get to try but would be fun. You could run all of these invariants in production as well and sort of run them in the background if you can afford that performance-wise, and then if something trips any of the assertions, then you would just collect that ping on the server and then analyze that and then try and fix the bug. So using the users as a fuzzer as well. This ended up being a pretty good method for finding performance bottlenecks, because sometimes the fuzzer, because it picks random values for things, sometimes it might create events that have massive amounts of teams with massive amounts of players, and the app slows into a crawl because there's some rendering logic, for example, that doesn't deal well with big data sets. And finally, sort of the same thing. Would be fascinating to try and use this for finding memory leaks, in that you take a heap snapshot, then you run it for a while, and then you take another, and you see if you're leaving something dangling. And yeah. Anyway, that's all. Any questions? Yep.
Yeah, so if I understood correctly, you're calling the like the functions directly instead of, I mean, you could use like PhantomJS or a headless browser for clicking around, like really clicking around the app. Have you thought about that?
Yes, we could. The fact that we're instead rendering the app to an HTML string is very beneficial in that we are already kind of paying the price of this, the vastness of the search space, in that. And rendering the app to an HTML string is very fast compared to like a headless browser, for example, interacting with it. I would say that it's orders of magnitude faster. So then if you say that it took like, I don't know, 2 days to find 2 bugs and it was a month of linear time, then I don't know, it would probably be years of linear time if you use something like, I don't know, Puppeteer. If you use something like Selenium, it'd probably be eons, I don't know. And half of them would be false positives anyway.
Like limit where it clicks, like some kind of.
Yeah, it's a very good point, and I think that's why I said that it was somewhat surprising that we didn't have that many false positives. But the app is also very carefully designed, I would say, to be able to run headlessly, sort of just dispatching the actions. In that there's very little code that is outside of the actions, if you know what I mean. In that, in like click handlers or anything, we try and immediately call the actions so that there's not much code that cannot be tested via the actions alone, if that makes any sense. Yep, go ahead.
Yeah, my question is actually the opposite. Why did you crawl the HTML instead of inspecting the state? Is there a lot of like template logic or something like that should be actually refactored to business logic somewhere else than the template, or what was the reasoning behind that?
That's another very good question, and the answer would be that we attempted to get as close to being the actual user, in that we would observe the actual UI instead of just hooking up into the app internals, because it doesn't really matter if the app internals are correct if we're showing the wrong thing to the user. But again, we tried to do it in a way that would be reasonably fast in this kind of like, this is effectively the same thing as doing server-side rendering with React. And we're actually using the exact same methods. Yep, go ahead.
You mentioned a couple of bugs, the type of bugs that you found this way, and then you mentioned the sources of complexity in that particular project. I'm just curious, what was the top source of complexity in terms of bugs found this way, if you have that kind of statistic?
Top source of complexity.
Yeah, like among all the bugs that you have found, in what category of that source of complexity?
Oh, yeah. it's kind of hard to. It's probably 50-50 between the business rule violations caught by the invariants and then the traditional cannot call method foo of undefined kind of ones. It's TypeScript, but it's TypeScript not in strict mode, so there's still like a bunch of render methods and stuff that will blow up if you give them inconvenient data.
Yep. Lately we've been using machine learning with large test bases to kind of limit the tests that usually break with the new builds. So how would you take that approach in this fuzz-based logic and kind of like trying to find things that do break usually?
Yeah, that's a fascinating avenue of research, and I have like a vague understanding of it, but I wouldn't pretend to know a lot. I think what it would end up looking like would be kind of what the engineer walking into a bar ordering -1 beers and a lizard, so that I would imagine that the machine learning algorithm would eventually figure out these kind of boundary values, maybe, or I don't know.
Yep.
Good question,
Just
though.
like limiting the amount of testable stuff, so
Yep.
that it isn't really random every time.
No.
You were mostly like interested of the UI, but like, did you also test like kind of the data structure of the data itself, so it doesn't like write corrupted data to the database? Right?
I suppose that would be interesting as well, and more perhaps in line with the traditional meaning of fuzzing, in that you just try and like give the app garbage and see if it blows up. But we tried to do all of that, first of all, through the UI, because we want to, in the end, we want the user to have like a consistent view of things, and we want to make sure that happens. And through that, I suppose we would be able to, and we did verify a lot of consistency issues. But no, we didn't go as far as, I don't know, seeing that correct data gets written into the database. So this was part of the whole reason why this was feasible at all computationally, was that we focused on the Redux app, which has like a really fast way of rendering everything and trying different things. If we involve servers and databases and everything, again, it might be fast. It might be fast as in 100 milliseconds, but it's like hopelessly too slow for something like this, I would imagine. Go ahead.
Yeah, but a specific question I thought about. Did you run like if the tester clicks buttons, or like does it sleep in the middle, or does it wait in the middle, or does it like do them?
No, it doesn't. But then, if you think about a Redux application that is designed to like be as pure of an implementation of the flux pattern, if you will, then if the app is sleeping in between and there's no actions being dispatched, you can sleep a millisecond or you can sleep a year. It doesn't matter, because the state changes can only be affected through actions, and actions can only be affected through your fuzzer. So,
Yeah. Okay.
does that answer at all?
Yeah, I was thinking of a theoretical situation where you like maybe click something and then you leave it for 24 hours, and then you click another button, and then your cache has invalidated or something.
Oh yeah, if you involve the actual browser. Yeah, sure, true. Yeah.
And then you log out and
Yeah. Makes it even more infeasible.
Yeah.
All right, if you have any more questions, you can probably find me afterwards. And yeah, that's it. Thank you.
Let's have a short break and start at 1:05. That's about 12-ish minutes or so.
Есть ли шанс задать этот вопрос прямо человеку?
Please eat more food.
change it all. Просто проект состояние, что требовалось все-таки сложные вещи, чтобы найти То есть, ну я не верю, что хорошо проект, он будет требовать таких сложных файлов. Только то, что я тебе говорил, когда это только когда ты разрабатываешь Intel процессор. Вот, то, о чем вы сказали, то, о чем я тебе сказал, Intel процессор, когда он существует в фазе свечения. Но там настоящий рендом, то есть я должен проверить, что все это правильно. И там тест очень простой, что он правильно вычислил.
And the code is there, so if you comment URL.
No, that's the idea.
Yeah, and slides are actually, they are there. So if you look at this URL, the slides and the code is there. I feel like when I open the code or something, absorb.
The only thing I can't do from forms. Yes.
It's good that we got all the technical stuff out of the way. And then I'm just gonna show funny memes.
Yes, thank you.
Good cop, bad cop. Kind of thing.
Yes.
I'm relying on other people to do stuff. Not having to do anything myself.
That came out so funny. Also, I'm so envious of this Twitch. They couldn't. Oh yeah, so you also have that live thing picture takes 4 seconds. I kind of don't like it because it clutters my phone with stuff I don't necessarily need.
One thing I don't like on this phone is I do like adjust it, but it takes a long time to adjust it, and then not all apps adhere to it either, so then I can share it's that awkward. I think it's good for like these like because it takes G4 and I think really it's not like it's kind of old, but I don't think there's any way I couldn't figure out some way that you could like download and just like does your phone do this as well?
Varmaan aika tuossa search-basissa on vaikea sanoa, että hukkuuko se kaikki vaan ja sitten me koulutetaan. Myöskään ei ole Nykyisen niin se voisi sanoa, että matemaattisesti tehty se tavalla, että ne törmäisi toisiinsa. Sitä ei tarvitse pitää muistissa.
Make a
По верхам, конечно. Ну, я вообще в восторге. Я люблю тебя же видишь. Нет, да. Ну, все JS. Комплексы, готовые решения. Единственное, такой разброс с людьми, кто получше знает, кто пенсионеры, если многие выпускники такие пенсионеры, бизнесмены такие положившиеся, молодежь, поэтому так интересно. Ну, по группам разбили, придумали проекты, я так еще не учился. Что в игры? Ну, такой, да, у меня группа получилась такая. Ну, такое приложение, которое я бы там считал калории, возраст и так далее, и приложил какую-то ну, в принципе, ничего нового. Ну, такой, что это баланс.
Jaskaburgerille sitten.
So, after this talk, the evening will be officially over. We don't mind you hanging around here. I was kind of thinking of heading down to the pub on the other side of the block and possibly using my company card to buy some beers for people that might also show up, just in case anyone's interested. Please, start.
Hi everybody! As was mentioned, I'm Juhis, and today I'm gonna talk about inspiration, learning, and experimentation in Codepen. So let's do a little bit of physical activity. How many of you have used or heard about Codepen? Almost everybody. Fantastic. For those of you who haven't used it, I hope that this talk will give another tool to your toolbox. And for those who use it or have used it sometimes, I hope it gives new ways, new inspiration, and maybe brings it back to your toolbox. The previous two talks were kind of tech heavy. I'm still a web developer, but I'm a bit less technical, and this talk is mostly gonna stand on the shoulders of other giants who actually create cool content so that I can just show it to you. Couple of words about myself. I'm a web developer, community builder, programming teacher, and you can find me on the internet mostly with the username Juha-Matti, on Twitter, GitHub, Codepen, Twitch. I started streaming open source a couple of weeks ago on Twitch, and that's been surprisingly fun. This profile card is the first example of Codepen. I didn't actually create this because I'm a very engineering type of developer, so that I don't know anything about design. I cannot make things look good, and that's why I love Codepen. So this one was created by little snippets, and everything in Codepen that is public is MIT licensed, and they have existing functionality so that you can fork any project. So I just searched for profile, forked it, entered my own stuff, and now it's on my Codepen, and it's on the slides. That's most of my usage that I use on Codepen, but let's talk about that later. Many of you might remember the world before. If you wanted to share some code on IRC or some forums, you probably pasted it on pastebin.com. It did give you syntax highlight, but that was pretty much it. It was horrible to use. And after that, there has been other tools. There's JS Fiddle, JS Bin. You might be familiar with those. And they're not that different from Codepen. But at the end, I'm gonna do a little bit of comparison. But for those of you who haven't used it, this is what it looks like. You get HTML, editor box, a CSS, and JavaScript. Then you just type the code. You get a preview window, and that's all you need to do. Every time you click save, it's online, it's public, you can share it with your friends. I'm gonna talk about 4 things today. Inspiration, learning, experimentation, and I left the 4th one out from the title for 2 reasons. First of all, the title started to get quite long, but I also wanted everybody to listen until the end. But let's start with inspiration. The kind of motivation for this talk is to inspire you. But I'm the kind of guy who gets easily inspired. When I first heard Jarno's talk at that Futurist during the summer, I got really excited about fuzzing and monkeys and all that stuff. And that's how I got involved with Codepen. You can see on the top left corner, there's a webcam. And there's this one shy blob. We can all probably relate. When somebody's looking, you're a little bit blushing. You don't want to dance. JavaScript. And the shy blob is just one of the cutest things I've seen. And when you see this kind of stuff shared on Twitter or Flowdog or Slack, you're kind of drawn into it. And the technology behind this is relevant. It's not just some random animation. It's actually using the real webcam. And with Codepen, every example you find, you can just click Editor View and you can see the code. And you can learn and kind of figure out how it's done. The second example is by a guy called Shaw. I call it an alpaca dating simulator. And as you can see from the video, I'm not very good at playing it. But it's basically, you get two controls, two alpacas. If you've ever played the running game, where you have to punch different buttons for different limbs, this feels kind of similar, and it's also quite difficult to play. It's 500 lines of JavaScript, and you can learn how to do controls, how to do these kind of animations, how to build the game world, how to do collision detection. So while it looks cute and fun on the surface, the depth of the tech that you can learn with these kind of things is pretty amazing. The third example on the cute and artsy category is Totoro. This was maybe one of the first ones of these kind of things, like really fun, experimental, cute, that I found from Codepen. I was actually looking for how to make a custom checkbox with CSS. Because the basic HTML ones are just crappy. So I just googled like Codepen custom checkbox. And I didn't expect to see this, but I'm happy I did. I'm a huge Studio Ghibli fan. I love everything about this, and it's super simple technically. It's just a checkbox with some CSS animation, keyframe stuff. And when you read through the code, you're like, how can it be this simple? And if you ever want to do something like this, for example, for like company-specific stuff, branded, maybe like the Vincit duck rolling over or something, you can just take this code and kind of figure out what you need to change. So for me, Codepen acts as a source of inspiration. I follow a lot of front-end developers on Twitter who do these kind of things. And I get excited, and then I get to learn. But not everybody is excited about cute and artsy. But there's other ways to learn. Many of you might have seen different kind of guides on GitHub, where you make like readme.md, and then you share the link. And that's the guide, or tutorial, or some kind of documentation. But there's limitations in GitHub, especially that it's markdown. If you want to do some fancy, like, real-life JavaScript stuff, it gets difficult. If you want to do SVG animations, it gets difficult. But with Codepen, you can make everything in one. So let's continue to learning. I was hoping to do the first name dropping of the day, but Emily kind of stole it. This is from Sarah Trasner. It's a fantastic, super simple like app or documentation. So if you deal with JavaScript arrays a lot, but you don't always remember, especially when you're learning, like what's the right syntax, what's the right name of the function. So Sarah built this JavaScript array explorer. It has two drop-downs it's all open source, so it's wonderful. And this is the way I spend most of my time with Codepen. I search for components. So in this example, I've searched for login form, and I can see like dozens of different ways people have done login forms. And they are all much better than anything I can do. So I save my time, I get to learn. I've actually used the one on the middle by Eric on a project, and then I built the entire app around that color scheme, because I couldn't quite figure out how to change the colors. So you can also do that. And these kind of ways of learning over some, like you search for a tutorial, then you read for 5 minutes before you even figure out if it actually helps you. With Codepen, every example is a small, isolated component. So they are usually much easier to just take and put somewhere else. I've read hundreds of tutorials, and sometimes you just want to start in the middle, and you want to end before the end. But there's often so much other stuff that it's difficult to make that piece of thing working as it is. But with Codepen, no problem at all. If it works on Codepen, you can most probably and most likely just take it, put it on your React component, and call it a day. Then the third part is experimentation. So I'm a full stack developer, so I have to build a lot of different kind of components, also for myself. And as I mentioned, everything happens in isolation, so it's kind of easy and nice to just hack something together. Here's one example. On one Friday night last spring, when the NHL season was coming to a close, I wanted to make a website, basically a small web app that would show who's gonna win, who's gonna be the best goal scorer in NHL. I was rooting for Patrick. Unfortunately, he got a little bit short. But I built it with Vue. You can barely see on the top right corner. At least they can see. But there's a Vue app. There's some HTML, there's some CSS. And I built it completely inside Codepen. And then I just kind of exported it, built some functionality around it, and made it a website, and deployed that. But I was able to build all the CSS, all the functionality, how it works, how it looks like, inside Codepen, and that was wonderful. Another thing that I really like is that it's not just HTML, CSS, and JavaScript. Not just the vanilla basic stuff. You can add preprocessors. So if instead of HTML, you prefer something like HAML, you can use that. If you want to use Sass or less, you can use that for CSS. And if you choose Babel, and you add external libraries for React and React DOM, you can write React components with JSX without having to do anything yourself to set up the process. Somebody mentioned Code Sandbox on the previous talk, and I love that too for the same reason, that it's so easy to get started. But with Codepen, it's kind of a smaller piece of that. You don't need everything when you're just building a component. So this is just one component that I built on stream a couple of weeks ago. It doesn't show all together, but basically it's just a text area input. When you paste certain IDs into it, it will turn them into content editable list items. It will do an API call to an API, search for the picture, and then when you hover over, it shows the picture. I built it as part of one of my applications, but I did it in kind of isolation, so that I didn't build all these dependencies environments in JS Bin and JS Fiddle, which look pretty much the same as Codepen on the editor side. But what they don't have is the community. I've already shown a couple of examples of the amazing people like Cassie Evans and Sarah Krasner who actively build stuff for other people to learn. But Codepen is also super active on that front. They have monthly challenges. This month, on November, we're talking about animals. So each week, there's some kind of a prompt. On the last week, it was pandas. So people would create dozens of animated SVG pandas, or some kind of components that relate to pandas. In October, it was Halloween. On July, it was The Office, where they created like nice-looking things out of the boring stuff like tables and forms. And I'm pretty willing to bet that December is going to be about Christmas. And I hope that many of you, if you haven't taken part in the community challenges, would try it out. Then you get to see everything other people build. So I can just go, click on the pandas, and I get unlimited amount of pandas. It's like Imager, but better. And these kind of things, if we think about the Halloween, if you're running a small business and you want to add something fun to your website during the Halloween, you probably don't want to put a lot of effort and like people time into it. But you can browse these and find cool stuff and implement that. You can kind of notice a pattern that I'm really lazy. I'm willing to bet most of you are too. That's maybe the most characterizing characteristics of a developer, that we are lazy. And that's why Codepen is so cool. Not only you get to learn and experiment, but you get to kind of take the open source in small pieces that is more approachable, easier to fork, easier to experiment on. And for each pen, there's the traditional basic commenting section. This one pen has thousands of comments from people around the world. So you get to interact with people who find what you build valuable. Or if you find something valuable, you can tell them that. We all love to get some recognition and credit for the hard work we do. So that's fantastic. I started the presentation with the best one, the Shy Blob, my absolute favorite. But I also wanted to end with something really cool. This is called, I think, The Last Experience. The name will be on the last slide, but I forgot it. And it's HTML, CSS, JavaScript. They start dancing in like good manner. And when you click individual pieces, those pieces will do something else. So this is a mess that I created by fuzzing around. I'm Juhis. You can find the slides on meetup page. I will also post them on Facebook and on my Twitter. Thank you. Any questions, comments?
Does the Codepen keep any history between saves? If you like create something and save it and then change something and save it again, can you go back in the history?
I don't actually know. I've never encountered the situation where I need to. I don't make mistakes. So that has never happened to me. There's no obvious like version control stuff. So I haven't seen. If somebody knows, you can share. If not, we can Google together at the end. But yeah, I don't know. But one thing they do have related to kind of that is, if you fork a project, it will always have a link back to the original. So it will always give the credit
said something about exporting something from Codepen. Did you have to like copy paste the code somewhere else and deploy it to Netlify or somewhere else?
Oh yeah, there's no kind of like one-click deploy kind of thing. Mostly because you don't build like full stack of it. You don't even have to put all the HTML. You can just start with something like H1 and then do only the things that you need. I mostly just like download it. I think there's like download as zip file functionality. I might miss that with the Code Sandbox. At least Code Sandbox has. I think Codepen has too. But you can also just copy paste. Usually the amount of code that you write in the Codepen component is relatively small. That it's faster to just copy paste into an existing code base than to download a zip, unzip it, move the files, and build the bridge. Yeah.
Is there like some premium version of Codepen or something like how they make money? Do you know?
So they have a pro version, which basically allows you to have private pens. That's the like main selling point. There's probably some other stuff too, but yeah.
Just to add to that, I'm actually a paid user of Codepen, and we use it in our company for online courses. We do online courses about web development, including HTML and JavaScript and CSS. And with the paid Codepen, you can embed your Codepen project and allow users to actually like fork without doing anything just on that page in the embedded stuff, which is really awesome. Like if you make a tutorial or something, you can embed something and people can play around with the existing code without going on Codepen.
Yeah, that's right.
So for the internet viewers, one of the extra points that you get is that you can start embedding stuff. And I mentioned earlier that the license is MIT. But if you have the pro version, and if you do private pens, then you have the copyright. So then it's not MIT. Only the public pens are automatically and always MIT. If there's no other questions or comments, I'm also gonna stick around. I'm gonna take on Emily's offer of free beer. Feel free to, ask anything, comment. All the slides will have clickable links to the projects that other people had made. So if you find the slides, you can find all the cool, artsy, and cute stuff. Thank you.
Thank you, everyone, for being here and for listening and being a good audience. A fine audience, yes. I would love to once try what you've got going on with your voice, because it's a wonderful way of making sure everyone's really silent. But yeah, I figure of heading over to Kaisline, maybe something like 15-ish minutes, and if you want to follow, I have a card, and we'll see what
Cool. 15 minutes.
Something like that.
Okay.
There's still more food if you'd like to eat some or take some or,